Okay, I have started recording the session. So, yeah, recording started. It is capturing the screen. Okay, fine. So, okay, welcome Patlika and Shivam. So, today is our 13th lecture, and I will be solving assignment number 12. So, this will be our last class for this course. Here, water molecule is zero. So, question number 1. Given the character table of C3V, why this water molecule is given here? Anyway, considering the reducible representation, tau, its irreducible components are. So actually we have to find the irreducible representation. So this I don't know why. Oh, this I don't know why it is given. Okay. Anyways, but we know how to do this using this GOT, Great Orthogonality Theorem. Okay. A1 is equal to 1 by H summation I in bracket xi and x I of r. So this formula we are supposed to use. So here character table is given, reducible representation is given. So basically we have to multiply. That's it. Nothing else. Tell me. So tell me what is h here? Anyone? Patlika and Shivam. Okay. So order, like what is the order? Yes. So order is 6. So now what we have to do? Just we have to multiply these with a1. So 1 multiplied by 1 multiplied by 6 plus 2 multiplied by 1 3 plus 0 3 and 1. So this is 0. It is like 1 by 6. It will be 6 plus 6 will be 12 by 2 2. Correct? So a1 is 2. So irreducible representation will be 2a1, right? So we are trying to find out the answer now. So how many options have 2a? 2a1, option B and option D, correct? So this cannot be your answer, this cannot be your answer. Now option B, according to option B, it is 2a1 plus 2e, and according to D, 2a1 plus 2a2 plus e. So we can solve for any of the symmetry species, a2 or e1, we will easily get the answer, right? So for, let's say, solve for a2, 1 by 6, then what will be the answer to this multiplication? 1 6 1, and then 2 3 1 and 0. 2, right? So your option should be, this also rules out option B. Only option remain is option D, plus 2a2. Okay, if you want, you can also solve for a e. So 630, 630, 1 2 3 1 2, this is 0, and a2, 2 minus 1 0, 2 minus 1, this is already 0, it will be 1 by 6, 12 minus 6, 6 by 1. So your irreducible will be, irreducible representation turns out to be 2a1 to a2 plus e. Yeah. So D, option D is correct. Okay. Now moving to question number 2. Using character tables and standard working formula, using assign the IR active modes for ammonia. So ammonia is this. Structure of ammonia. Okay. Tell me, what is the point group then? What is the point group? D3H. Okay. So you are saying, Patlekha is saying D3H. How come point group is D3H? So Shivam is saying Shivam C3V. So out of both of you, who is correct? This ammonia is like this. Two here and one, let's say this here. Three bonds. Three bonds. And you here are the loops. These lone pairs. So from the above, the axis of rotation is passing through these lone pairs. Then you can rotate these. Like all of these NH bond are 120 degree from each other. The angle between these 120, 120 between these two is 120. So answer should be C3V. Cannot be D3H because it does not have um, this sigma H. Molecular plane. Okay, so C got it. So now we need character table of C3V. Then we will able to find it out. Okay, character table we have here. What are the symmetry elements are present? E C3 sigma E C3 sigma V 2 2 3. Now how to solve it? This we, this type of questions we have like done in previous assignments also in previous classes. So first we have to find the reducible representation. So number of unshifted atoms. Tell me for E operation how many number of unshifted atom will be there? 4. And for C3 1. Sigma V 2, yes. Now we have to find out the character per atom. Is in the character table, you can easily find it out actually. So for E, what will be the character? 3. Okay. For C2, C3, 0, yes. And for sigma B, sigma B 1. So tau total will be 12, 0 and 2. This is your reducible. Now we have to find the irreducible. We have to break this in irreducible representation. Then we will be able to find the higher active Raman active. Okay. So how to do this? This in the first same formula. IH 1 by H summation I, right? Now let's move to another slide. 1202. 1202. Tau total irreducible. And then okay, you need character table also. So these are for E, 2C3, 3 sigma B's. A1 character table for A1, for A1 1 1 1, A2 E 1 1 minus 1, 1 1 1 minus 1, for E 2 minus 1 0, 2 minus 1 0. Now I have given everything. Okay, let's calculate contribution of A1. What is the order? Okay, so 1, 12, 1, 0 plus 1, 2 and 3. What will be the answer? Yes, will be 3. For A2, What will be the answer? One, yes. For contribution of E to E. Mm, Tell me the answer. 4, yes. So irreducible will be reducible representation with 3a1 a2 plus 4e. Okay. Asking for assign the IR active modes of the ammonia. So this is total. Irreducible representation. This is total. Total much 3 1 3 1 4e. Now T translational. Look at this character table of C3V and tell me what will be the symmetry species in the translational irreducible representation. A1 and E. A1 plus E. Now T rotational. E and A2. So we have to subtract from tau, I mean the total, these translation and rotation, then we will get the T vibrational, tau vibrational. 2A1 and these will cancel out. 2A and 2A2. 2E. So how many vibrational modes will be there? How to calculate? Total vibrational modes. 2 into 1 plus 2 into 2. 6. Right. Also you can find it out by this is linear molecule, no? Not linear. So what will be the formula for it will be 6. So how many atoms are there? 1, 2, 3, 4. See? 6. So we are getting 6 modes, vibrational modes only by solving. Out of these, question was find the higher active modes of ammonia. Only A1 and E are here. Okay. Using this character table, tell me out of A1 and E, which one is higher active, which one is Raman active? I mean, just tell me first which one is higher active. Okay. So Patlika is saying both of them are higher active. Yes, it is true because this XYZ should transform according to the that symmetry representation. So yes, A1 and E. Okay, out of these, how many are Raman active? So both of them are higher active. Okay. Yes. These two also Raman active. Because we have to, for checking the Raman active, we have to find the quadratic term should transform according to the symmetry representation, right? So these two are, so here in case of NS3, both vibrational modes A1 and E are Raman as well as higher active. Yeah. So our option should be D. Question asking for higher active modes, correct? Okay, let's move to question number 3. So question is saying transformation matrix for clockwise rotation of unit vector along xyz direction by angle theta with respect to y axis is. So y will remain constant. Let's say this was your point. Now it will, this is your x1, z1, x2, z2. So upon transformation, so this is y. Okay, so upper transformation, this should change their sign. Basically, rotation along y-axis by angle theta. So x and z will change sign. So do you remember these trigonometric metric identities? Cos theta minus alpha equal to cos theta cos alpha minus plus sin theta sin alpha, and one will be sin theta minus sin alpha equal to sin theta cos alpha minus cos theta sin alpha. It will be after the rotation. Let's say this is your theta total, and this is alpha. This will be theta minus alpha. These coordinates coming after the rotation along the y-axis y angle theta. Now it is pretty much simple. So how to write this x1? X1 will be let's say length is L of the vector. So L cos alpha plus L sin alpha. No. L cos alpha x and Z will be L sin alpha. Next, for x2, it will be L. It will be L cos, not sin. Cos theta minus alpha. So it will be L cos theta cos alpha plus sin theta sin alpha. L cos theta cos alpha L sin theta sin alpha L cos theta, no, L cos alpha. This is x1, right? Cos theta plus this, and this is sin z1 sin alpha sin theta. These are x coordinates. Now z2 will be L sin alpha theta minus alpha. L sin theta cos alpha sin alpha minus L sin theta cos alpha plus L cos theta sin alpha. This should be minus. Then this will come because sign is changed. So Z2 will become like minus x sine theta plus Z1 cos theta. So transformation matrix will be 3 by 3, 3 by 1, x1 y1 z1 x2 y2 z2. We already know y1 equal to y2. This is unchanged, y2. So 0 0 1 0 0, right? Now try to fill it up. Z2 is the combination of, tell me. Tell me what will be the transformation matrix. Should be cos theta sin theta minus sin theta cos theta. You can also check. Z2 will be what is Z2? Minus x1 sin theta. So it will be minus sin theta. And then Z1. So multiply this cos theta. Similarly, for x2, it will be x1 cos theta. X1 cos theta. This multiplied by and Z1 sin theta. So Z1 sin theta. And these are 0. That is it. Cos theta sin theta minus sin theta cos theta. So this is the answer. Option A. So is it okay to you guys? Okay, sir. Okay. So this is the transformation matrix along y-axis. Or I would say for rotation along y-axis, y angle theta. Okay, moving to new question. Next question. Partial character table of C4V point group is provided below. Using the character table provided in question 9. Question 9. There are only 6 questions. Anyway. Without referring to any other resources, symmetry of RZ is. Symmetry of RZ means ZX and by rotation along RZ, Z direction. Any response? Okay. So try to rotate around this Z axis and see after applying the symmetry operations what will be the character.
Okay, I found this on the web. Can see after applying the symmetry operations what will be the character.
Apply this operation E. Nothing will change, so it will remain 1. Now you can solve. I'm not asking for the number of unshifted atom. Your answer is 3, 3. So that is why I'm saying that I'm not asking for number of unshifted atom. I'm asking for the corrector by applying E along Z direction. So what will be the corrector of C4 along the Z direction? And its principal axis of rotation is Z only. It will change anything along the Z direction? No. So corrector should be 1. For C2, it is also along the Z direction. They are asking the symmetry for RZ. So corrector should be 1. For sigma V, should be -1. Sigma D, it is -1. Because let's say this is your principal axis of rotation here. So E is 1 only. C4Z, it is just rotating your molecule. Z axis is not changing. So RJ will this RZ, symmetry of RZ, it will remain 1. For sigma V, may even if it like the plane is YZ, even it contains the Z axis, but it will reflect. So by rotating, it will change your orientation. So that is why the corrector is -1 for sigma B and sigma D. Now try to see which symmetry species is having these characters out of these. Now you tell me the answer. So then it will transform according to that symmetry species, this symmetry of RZ. Here we have, this is the half only, half character. Here we written x y z r z x square y square minus y square, quadratic term, linear term, rotational term. So RZ belongs where? Yes, it is E2. Done. Fine. Okay, moving to next question. Using character table and standard working formulae, work out the symmetry of normal modes of vibration, total vibration mode of protein. This is the structure of protein. First, tell me how many number of atoms are here in this molecule. Yes. So what will be the formula to calculate the number of vibrational mode? 3n minus 5 or 6? 6, yes. Because it is not linear. Okay, using this formula, let's find out number of 33 minus 6, number of vibrational modes. 27. So one shortcut is calculate the number of modes using these in the options. So I'm only 3, 3, 5, 10, 13, 15, 13, 18, 18 and 9, 27. Right? Or else you can do this reducible representation and then try to find it out. This is a simple way of finding out the, see in the, just like in the last year, where here total number of vibration mode I have calculated. So you can calculate for each of the option. Option A. Option A is 2 1 plus, sorry, y2, 1 into 1, 1 into 1 plus 1 into 1. 1 for coefficient, and for A and V it is 1, for E it is 2. So total number of vibration mode is coming 3. But here we have calculated 27. And for option B, tell me how many number of vibration mode will be there. 3. And for C, 27. Option D, 5. But this can mislead you also, because option. Okay, first tell me what is the point group of protein. CS. How come point group of this is CS? So basically, Shivam is able to see only the sigma H. Yes, no, but you look closely. No, you can find it out. Other symmetry operation elements also. Axis. See, these are in resonance. Now try to find it out. Like, it is our last session and still you are not getting the point group. It is very, like, you should get it. You should get the correct answer. Yes, one C2 is present here. This C2. Is it C2B? Yes, the point group is C2B. So this option actually not correct, 27. So to work out this problem, we need a character table of C2V point group. Okay, so while looking, we can see here A1, A2, B1, B2. All of them are there. So A1, A2, B1, B2. Okay, while looking at the character table, why don't you tell me that which one is IR active out of the symmetry element, out of the symmetry species, which one are, which one is, which one are these IR active? This is also one exercise you should know. Yes, A1 plus B1 plus B2. So that is why you are correct. A1 plus A2 plus, oh sorry, B1 plus B2. These are IR active. So this option is not correct because it contains A2. So which option is this? A1, B1 and B2. This option only. Here we have A2, here we don't. So this rules out. Here we don't have B2. So this rules out. Only the option 1. But question is asking using the character table and standard working for work out the symmetry of normal modes of vibration of protein. So basically question is saying you should work out, not try to, like, the question is asking for the full derivation. This you know how to do it, but we can also do character table of C2. We need character table. Okay, here we C2V, C2 sigma V, this XY, XZ, YZ. Okay, so number of unshifted atoms of pyridine. Y applying the operation E. Eleven. Sigma XZ. Oh, E is not written yet. I should write E also here and C2. Okay. What about C2? How many number of atoms will remain at this at its position at their position by applying C2? 3. For sigma xz, 3. Sigma yz, 11. It should be 11. One plane is like this, another plane is this, because your C2 is this. No plane is perpendicular to this because this point group is C2V. So that is by 11. Okay, corrector. Now it's time to find out the corrector. Corrector is 3. I don't know. Like every time you are writing 3, 3, 3, 3, 3, so I'm seeing only 3. Anyway, corrector for C2. Mm, how to find the corrector? Tell me. This is very simple, and you are like again making the same mistake. You are making the mistake finding out the point group, character with this. Even though if you are having this character table in the front of you, it is minus. You have to add these, no, these linear terms. For C2 it should be minus 1. For sigma v, xy, this xz, it should be plus 1. Sigma v, yz should be plus 1. Tau total. So what will be the tau total? Tell me. For E2, 33. Next for C2, next sigma v, yz. Yes. Now break it into the sum of the irreducible representation term using your this formula, the same formula. So what is the order here? H. Order is 4. So for A1 is equal to 1 by 4, 1, 1, 1, 1, 1, then 33 plus 1, 1 minus 3 plus 1, 1, 3 plus 1, 1, 11. It will be 33 minus 3 plus 3 plus 11 divided by 3, 3, 3, 44 divided by 3 equals to 4. Right? Is it okay till here? It should be okay, sorry. Should be 4, it should be 4, it is 11. A1, 11 even. Similarly, if you do for A2, B1, B2, for A2 you will get 7B1 and 11B2. So tau total will look like this is okay, right? This you can do by yourself. Yeah. So it will look like 11 A1, 4 A2, 7 V1, 11 V2. Now you need T translational, T rotational. So translational, tell me what are the symmetry species will be there for tau translational by looking at this character table. Yes, correct. A1, B1, B2. Now for translation rotational. A2, B1, B2 is A2, B1, B2. So for tau vibrational, it will be 10 A1, 3 A2, 5 B1 plus 9 B2. So for protein, pyridine 10 into 1, 3 into 1, 5 into 1, 9 into 1, it will be 27. Normal vibrational modes. But using the character table, we can find it out that only A1, B1 and B2 are the IR active mode. Out of these normal 27 normal vibrational mode, IR active is only A1 and B1 and B2. So tell me how many number of vibrational modes are IR active? Arey, that you know, A1 plus B1 plus B2. These are your symmetry species. Now I'm asking the number, IR active modes. How many number, how many IR active modes are there? So basically you are saying 3. So out of 27 normal vibration mode, you have only 3 active vibration mode, 3 active IR active modes. Or you have to subtract these, no? This A2 is not IR active. Why? According to this character table. So these are not IR active. Rest of them are IR active because rest of them belongs to A1, B1 and B2. Here we have linear term. So all of subtract these 27 minus 3. So we have 24 IR active modes. Is it fine to Shivam? And Patlekha, you have understood how to calculate these IR active modes. It looks like you have forgotten. Like your exam supposed to be happen on 25th or 26th October. So be prepared. Anyway, moving to next question. This question we have covered in our previous class, like in previous assignment, one of the previous assignment. If you remember, tell me what will be the answer. Okay, looks like you don't have any clue. This is similarity transformation. So trace of A will be equal to trace of B. They are asking trace of A. So along like under this similarity transformation, your okay, your traces or character remain unchanged or same. That's why all the symmetry operation belongs to the same class, have the same character or the trace. Okay, we are done with assignment. If you want the proof of this, then it will be proof if A and B are conjugate to each other. They belong to the same class and have same traits. Trace B VII equal to separating A Z K K Z I K Z K. So the trace of B will be Z equal to K E Z K Z K. This is Kronecker delta. Trace of B summation of Z summation of K A K Z Kronecker delta I K equal to summation of K. This is equal to trace of A. So thus trace A is equal to trace B. Answer I have already given you trace B. Proof. Okay. So this was the proof. Answer is B. Okay, we are done with the this assignment, and all the assignment I have solved, and still we have few like 30 minutes. So let's solve these point groups. G. You're saying C2V. This is X. So your molecule is X and this is Y. From where C2 will pass for this molecule? No, it cannot be. So it should be like they are above the plane and below the plane. So it will flip your molecule. So X will go down. How can this C2 be? You need to really buck up. Otherwise, you are still not getting the point group. Like this is your plane. X is here, Y is there. Y is down there. X is here. So anyway, if you pass this diagonally X, this C2, what will happen? Like this. So this X will go down. How this orientation is not matching? No, orientation will change. Are you getting my point? Then sigma V can be passed. How to find the point group? You don't remember how to find the point group. First, you have to look the higher order symmetry. Then you have to look for this linear molecule or not is there or not. First tetrahedral, octahedral, icosahedral. Then you have to look for this linear sigma infinite, C infinite, D infinite. Then we come for these C2, C point group and D point group. Then first we try to find out the axis. Then we find out the plane, the axis perpendicular to other axis or not. Then we find out the plane. So this is the order. Did you get it? Yes. So what will be the point group? Tell me. It is CS. Anyway, moving on. Find the point group of this K. CS, CS means? Okay, okay. Okay, tell me, the point group of this is CS or not? Okay, you have said also this. Shivam, then sigma V can be passed. Then after that you have said CS. Tell me, this CS is point group or not of this molecule? When the sigma V you are saying this should be sigma H and which contains the whole molecule. Then the point group should be CS. This molecule looks very easy, but they are not very easy. CS means E symmetry operation and sigma H, which this sigma H contains your molecule. So whatever you are saying that it is passing diagonally, it will not contain your molecule. So sigma H is not the operation who remains your molecule in the same orientation. What will be the point group? So point group should be E, is this, C1. Should be C1. Only E is present here. Next, find out K. Point group of K molecule. So Shivam is saying C2V. One C2 I can find here. No, no, no. This is not a C2, right? It will fill up your molecule. No, this is not the C2. This is your C2. C2B. But this plane is perpendicular to this. This plane is C2B. This sigma B. Which is perpendicular to C2. Then tell me the point group. Yes, C2H. Why you are making mistake in finding the point group? This is very easy. Anyway, find the point group of H molecule. Any response? This you have to work it out because this is our C1 for H molecule. How come C1? Because if you take this C2, anyway it will flip their molecule, so that is why. But you are not looking closely. It is quite symmetric. You have to look closely. That is why I've taken the pause. Look closely. There are three axes, three Cartesian coordinate, right? X, Y, and Z. So you have to look in all the three directions. Then try to find the axis of rotation. Yes, it is C4, then don't have sigma H, C4V. Next, I. Here, this is what L. Okay, any answer? I lost the connection, but again restore the connection. D2. Yeah, D point group is there because there are three C2 axes are present along all the direction, along all the axes, all the three along all the three axes we are able to see the C2 axis, C2 axis of rotation. Yes, but they are not perpendicular to your C2 axis. So the point group should be D2V. Two plane passing diagonally, yes. These diagonal planes are not perpendicular to any of the C2 axis. So this should be D2V or D2D. Because D point group only have sigma D and H. and then we look for sigma d. And here d are present because these diagonal elements, that these diagonal planes are bisecting these your C2 axis. So this should be d to d. Is it okay to both of you? Just reply yes. What Patleka? Okay, fine. Next, I molecule. These three molecules we have to finish today. C2H. Okay. What about Patleka? Okay, she is also saying C2H. But this diagonal here C2 axis is passing. Correct? From here C2 axis is passing. Correct? One from the top, this C2 axis is passing. Correct? This C2 axis. Now tell me what will be the point group. D to D. So consider this is your principal axis. Don't you find any plane which is perpendicular to this C2 axis? If there is any plane, then it should be D2H. See, these molecules were looking very simple, like just cyclobutane and at few positions, one, two, three, four positions. In few positions, in few molecules, there are substitutions D2H. Yes, substitutions were there. So by looking at these it, molecules, it is very nice and pleasant, but finding the point group is difficult. The answer of this question is T2H. Still, you're taking so much time to find out the point group. Anyway, these last two molecules are there. Just try to find out within 3 minutes. Then I will close this session and we will say goodbye to this course. Hopefully, we will meet in the next course whenever I'll take. I will be as a TA. So anyway, what is the point group of M molecule? One C2 I am seeing here, correct? No, no. Even if you have plus C2 here, they will go there. No, this side also there are no C2 present. Yeah, exchange their position. Similarly, exchange their position. Diagonally, they will go up and down, up and down. From above, we will exchange their position. No rotation I am able to find out. Rotation axis for this molecule. Are you able to find out any axis of rotation for this molecule? If sigma is not there, this rotation is not, no, yes. So rotation is not there, then simply this is sigma s is also not present. I is also not present, correct? Then what will be the point group? What is left? C1 only. Okay, for this molecule, this C2 axis I am able to find, I think, because this will go down, this Y will be above the plane. So yes, this C2 is there. And from above the, it will x and y. So no, this is not. From here, this is also not present. So only one C2 I am able to find. One sigma plane which is perpendicular to this is there, right? Which contains these all the four molecules and the diagonal of this diagonally, right? Yes. So now tell me what will be the point group, because D point group cannot be possible here. Only C is C2 and then this C2H. This point group should be right. Okay. It was nice teaching you guys, and today was our last session, and this course last session. Probably I will be meeting again in January for another another class, this another course. Till then, see you, and I'm closing this session. Bye.